Good morning, sir. This is my project presentation presented by Augusto Louise Alejandro. For my topic is the introduction of trees. Trees are used to construct efficient algorithms for locating items in a list. They can be used in algorithms such as Huffman coding that construct efficient codes, saving costs in data transmission and storage. This can be used to model procedure carried out using a sequence of decision. Constructing these models can help determine the computational complexity of algorithm based on a sequence of decision, such as sorting algorithms. So th- let's go for the theorem and definition. For Theorem 1, an undirect graph is a tree if and only there are unique simple paths between any two of its vertices. So, for definition 1, a tree is connected undirected graph with no simple circuits because a tree cannot have a simple circuit. A tree cannot contain multiple edges or loops. Therefore, any tree must be a simple graph. For definition 2, a rooted tree is a tree in which one vertex has been designated as the root and every edge is directed away from the root. So this, for example, the this tree and the root is G. It has two children, F and B. And B has children A and had a children D and C. C has a children E, and this with root A, you can see A having three children B, C, and D, where B had two children F and G, where C had an child E. With root C, it has two children on the left, on the right side. It has its E, and for the right side, for the left side is A. For A, its right children is D. For left children are B. For B, its children are F and G. Example 1. Tree is connected undirect graph with no simple circuits. First, the first three are connected graphs with no simple circuits. Here is the root, and these are its children. First dot, second dot, and third dot. The third dot has a child, and its dot has also a child. And for the second tree, it's not a tree dot, not a tree. The dots are center are not tree. The dots are simple circuits in this graph where it's loop, as you can see. For the finally, the third tree is not a tree because it's not connected here. Terminology of tree or trees. If B is a vertex in T other than the root, the parents of B is unique vertex. You such that there is a directed edge from U to B. The reader should show that such a vertex is unique. When U is the parent of V, V is called child of U. like in this root in this tree, you can see the C is the parents of A and E, where A and E, their parents are C, which A and E are siblings. Vertex with the same pattern are called siblings, like I said earlier, A and C, A, A and E are siblings. The ancestor of a vertex other than the root are vertices in the path from the root to this vertex, including the vertex itself and including the root. The descendants of a vertex V are those vertices that have V as an ancestor. Like here, the descendants of C are F and G, where F and G, their ancestors are C. A vertex of a tree is called leaf if it has no children. Vertices, vertices that have children are called internal vertices. The root is an internal vertex unless it's it is the only vertex in the graph, in which case it's a leaf. Here you can see it's an leaf and A are internal vertices, where A had a children B and D, where B is the internal vertice and D are the leaf. If A is a vertex in a tree, the subtree with A as its roots is the subgraph of the tree consisting of A and its descendant and all edges incident to this descendant. Let's answer your figure 1. Here are the roots where root A has three children B, C, and D, where B has a children E, F, G, and C has children H, I, J, and D have a child K, where K had a children L and M. So the figure 1, the root A, while it has a children B, C, and D, B and C and D, B, C, and D are siblings. B had the children E, F, and G, while C had H, I, and J. D also had a child K, and K have a children L and M. This is what I said earlier. This make A, B, and C, A, B, C, D, and K parents, while E, F, G, H, I, J, L, and M lives, since they don't have like child or children. The descendants of A here is the L and M here. And the ancestor is A, since it's the start of the root. Thank you very much. That's all.